Today, we're going to pull back the curtain on the architecture that keeps the biggest apps in the world from, crashing. We're talking about microservices. It's an incredibly powerful way to build software, but it's also really complex. And that's why you need a smart set of blueprints or design patterns to get it right.
So, have you ever stopped to think about it? How apps like Netflix or Amazon or your favorite food delivery service handle millions of people all logging in, searching, and buying stuff at the exact same time? Well, the secret is, it isn't one giant, clunky program doing all the work.
The real answer is that they're built more like a city. So instead of one massive skyscraper trying to do everything, they have hundreds, maybe even thousands, of tiny, specialized buildings. We call them services. Each one handles just one specific job. So you've got one service for user logins, another for product recommendations, and a totally separate one that just processes payments.
But just like any city, right, you need rules of the road, traffic lights, street signs, a postal service, otherwise you just have total chaos. And in the world of software, those rules are what we call design patterns. They're the blueprints that make sure a whole city of services runs smoothly. So let's dive into 6 of the most important ones.
Okay, first things first. How does anyone from the outside world actually get into our city of services? We can't just have requests wandering in from anywhere they please. We need a proper front door.
And that front door is our very first pattern, the API gateway. It acts as a single, unified entry point for every single request that comes in. The best analogy? It's like the main receptionist in a huge office building. You don't just wander the halls knocking on doors, right? No, you go to the front desk and they tell you exactly where to go.
And here's what that looks like. See how all the requests, whether they're from a mobile app or a web browser, all funnel through that one single API gateway? It's like a traffic cop. It takes each request and routes it to the correct microservice inside, service A, B, or C. It handles all the important stuff like security, logging, and routing, all from one central, manageable spot.
Okay, but what if your mobile app users need something totally different from your desktop web users? A single receptionist trying to handle everyone might get a little overwhelmed. Well, that's where our next pattern, Backends for Frontends, or BFF for short, comes into play. Think of it like having a specialized reception desk for each type of visitor.
And you can see that in action right here. With 2 separate gateways. You've got a mobile BFF, which is totally optimized for apps. Maybe it sends less data to save on battery life. And then you have the web BFF, which serves the full-blown web experience. Each front end gets an API that is perfectly tailored to exactly what it needs.
So here's the bottom line. An API gateway is a fantastic, one-size-fits-all front door. It's simple and effective. A BFF, on the other hand, gives you a whole set of custom-tailored front doors, one for each specific type of client. It's all about picking the right tool for your specific job. Okay, so we figured out how to get requests into our city. Awesome. But once they're inside, how do all of those individual services find and talk to each other?
In this kind of system, services are constantly starting, stopping, and moving around. You can't just hard-code their location and hope it never changes. So you need a dynamic way for them to find each other. This is called service discovery. And honestly, the best way to think of it is as a magical, self-updating phone book for your entire application. So look here. When Service A needs to chat with Service C, it doesn't have its address memorized. No way. Instead, it just asks the central service registry. That registry is the single source of truth. It's always keeping track of the current, valid location of every single service in the system.
But what if services don't need to have a direct, real-time conversation? Not every interaction is a phone call. What if one service just needs to announce that something happened and then let anyone who cares about it listen in? Well, this idea is the heart of an event-driven architecture.
This creates a really flexible system. A producer service, let's say it's your order service, publishes an event like new order placed to a central message broker. Then other consumer services like the shipping department or the email notification service are just listening for that event. When they hear it, they react. And the key here, this is the magic part, is that the order service has no idea who's listening. It just shouts its news out into the city for anyone who's interested.
So, our services can find each other, and they can talk to each other. That's great. But what about their data? In a microservices world, you don't have one giant central library. Instead, each service is like its own little librarian, with its own private collection. And this, as you can imagine, creates a whole new kind of puzzle to solve.
The foundational rule for solving this puzzle is the database per service pattern. The idea is simple, but it is strict. Each microservice owns its own data, period. No other service is allowed to touch its database directly. If Service A needs data from Service B, it has to ask for it nicely through its official API.
And you can see that really clearly here. The video service has its database, the email service has its own, and so does the notification service. They are totally separate, walled off from each other. This is crucial because it ensures one service can't accidentally mess up or break another service's data.
Now, this independence is fantastic. It's great for scalability and for letting teams work in parallel without stepping on each other's toes. But, and this is a big but, it introduces a major challenge. How do you handle a transaction that needs to touch multiple services, like placing an order that has to update inventory and charge a credit card? It's a tricky problem, and it's the key trade-off you're making with this pattern.
So, if every service has its own little database, how can we optimize for both writing new data and reading existing data at the same time? Well, that brings us to a more advanced pattern, CQRS. It stands for Command Query Responsibility Segregation. It's a mouthful, I know, but the idea behind it is brilliant. What if we split the job of changing data from the job of reading data?
All right, let's look at the command path first. Anytime a client wants to change something, like create a new user, update a product, delete a comment, it sends a command. And that command goes to the command service. This entire pathway is optimized purely for writing data, as efficiently and as safely as possible. Then, when a client wants to just read some data, like displaying a user's profile page, it uses a completely separate path. It sends a query to the query service. Just think about Netflix again. They have millions of people reading data all at once. That's you watching a movie. But way fewer people writing data, like updating a profile. By separating these two things, you can scale each one independently to handle its own specific workload. It's a total game changer.
So let's bring it all together. These 6 patterns we've talked about, they're really the essential toolkit you need for building robust modern applications. They might seem a little complex on their own, but when you put them together, they form a really clear strategy for managing complexity at a huge scale.
So let's do a quick recap. The problem is managing external access. Your solution, the API Gateway or BFF pattern. The problem is getting services to talk to each other. Your solution, service discovery or an event-driven architecture. And for that tricky decentralized data puzzle, you've got the database per service and CQRS patterns. See? Each pattern solves a specific critical problem in the microservices world.
Look, these patterns aren't just abstract theories from a textbook. They are the proven, real-world blueprints used by the biggest tech companies on the planet to build applications that serve billions of people. So the only question left is, now that you've seen the blueprints, what are you going to build?